All right, let's jump right in. Today, we're going to travel back in time a bit to a really pivotal moment in database history. The year is 2010, and this machine, the Exadata X2, just hit the market. Now, you might look at it and think, man, it's just another server rack, right? But no, what was going on inside this box represented a massive, massive shift in how companies thought about their most valuable asset, their data. So, you might be asking, why was this thing such a big deal? Well, to really get it, you have to understand the world it was born into. Before 2010, if you walked into a big company's data center, you'd see that it was fundamentally divided. They were basically running two completely different shows, and it was causing some serious headaches for pretty much everyone. And yeah, this lays it out perfectly. On one side, you had what's called OLTP, your transaction systems. Think of this as the front lines of a business, all about speed, speed, speed. Processing sales, updating inventory, thousands of tiny, lightning-fast things happening every second. Then you had the other side, analytics, or OLAP. This is the strategy team in the back office, asking these huge, sprawling questions that crawl across massive amounts of data to find trends. And here's the kicker. The hardware that was great for one was just awful for the other. So what did companies do? They had to build and manage two completely separate, very expensive systems. What a mess. And this is where the story gets really interesting. Oracle comes onto the scene and basically says, hold on a second, this whole divided world thing, maybe it doesn't have to be this way. They asked a really simple but kind of crazy question. What if you didn't have to choose? What if you could have it all in one box? And that was it. That was the core promise. So simple, but so incredibly bold. One box, both workloads. I mean, just think about that. Taking those two warring factions, the rapid-fire transactions and the deep, heavy analytics, and promising they could not only live together, but thrive in one place. This was the start of something big. Now, this didn't just happen overnight. The X2 wasn't some magic trick. It was an evolution, a journey. You can see it right here. It started back in '08 with the V1, which was really just focused on that analytics side of things. Then, the huge thing happens. Oracle buys Sun Microsystems, which brings in some serious hardware muscle. So in '09, the V2 gets things like flash cache, a big deal. But 2010, the Exadata X2, that's when it all clicked. The hardware and the software were finally singing from the same sheet of music, ready to make good on that crazy promise of consolidation. Okay, so the big question is, how? How did they actually pull this off? How do you get these two totally different jobs to run on the same machine without, everything grinding to a halt? Well, the secret sauce, the magic ingredient, was a breakthrough that completely changed the economics of data storage. They called it hybrid columnar compression, or HCC for short. And look, data compression itself, that wasn't a new idea. We'd been zipping files for ages. But this was different. This was built from the ground up, specifically for databases. The absolute genius of it was that it could squish data down to a tiny fraction of its original size. But, and this is the part you really have to get, you could still query it super, super fast. And the results? Whoa. I mean, just look at this. This chart tells the whole story. We're talking about a typical 10-to-1 reduction in the storage you need. That's insane. Think about that for a second. Your data warehouse that used to take up rows and rows of expensive hardware, now it fits in a space a tenth of the size. This wasn't just a small step forward. This was a giant leap, a total game changer. And that one breakthrough, it created this incredible domino effect, right? First, your data's smaller, so you can just plain store more of it. Simple enough. Second, because there's less physical data for the machine to read, your queries just fly. They get a lot faster. And when you have all that extra speed and room to breathe, well, now you can finally bring those two warring worlds, transactions and analytics, onto the same machine. The end result? Your costs for hardware, for people to manage it all, they just plummet. You gotta put yourself back in that time. This whole pitch sounded, well, it sounded kind of nuts. Like it was too good to be true. To come out and say, hey, that massive, expensive problem you all have in your data centers, we solved it. Here, buy this box. That took guts. It was audacious. But here's the thing, it worked. For the companies that took the chance, the promises were real. They saw the savings and they saw the speed. So this brings us to the real impact. The technology was impressive, no doubt. But what did this actually mean for a business, for the bottom line?
How did this change the whole economic equation of running a massive database operation? This right here, this connects all the dots beautifully. It's so clear. You take a feature, like consolidation, and what's the business impact? Boom, lower hardware and administration costs. You take HCC, and what's the impact? Bam, huge storage savings. The whole idea of an engineered system simply meant the hardware and software were built to work together perfectly, and that meant faster queries. And what does that mean for a business? Faster answers, better decisions. It's a straight line from the tech to the money.
And this wasn't just felt in the boardroom. You could see it everywhere. You had the database admins, the DBAs, just staring at their screens, their minds blown by the compression they were getting. You had the CIOs, the bosses, looking at their budget spreadsheets with a big smile on their face. And maybe most importantly, you had the actual business analysts. Suddenly, they could ask a question and get an answer in minutes instead of waiting hours or even days. The whole company just started to move faster, to run more efficiently.
So, when all is said and done, what's the real story of the Exadata X2? What's its true legacy? Because it's not really about the specs, or a list of features. It's about something bigger. It's about a fundamental shift in how people thought about data.
For the longest time, the database game was just a horsepower race. It was like building muscle cars, all about raw power, brute force, just trying to go faster and break through the next bottleneck. The Exadata X2 came along and said, that's the wrong way to think about it. It was less of a muscle car and more of a high-speed bullet train. It showed everyone that the real win wasn't just about raw speed. It was about smart efficiency. It was about doing way more with way less by making everything work together perfectly. And that's really the ultimate takeaway here. The revolution the X2 started wasn't really about making things faster. It was about fundamentally reshaping the game plan for how big companies manage their data. This idea that you could have one single, unified, hyper-efficient platform for all your data workloads, that became the new goalpost. That became the new standard. And honestly, that legacy continues to influence how we design and build database systems to this very day.